Hello everyone. So in the last class we have designed the base plate for the column. Okay, and the dimensions of the base plate that we got was 400 by 350. Okay, and also we have calculated the thickness which was 12. Okay, now you see just after finding the dimensions of the base plate, okay, we also have to like connect the column with the base plate, isn't it? That means we cannot just keep the column directly over the base plate, isn't it? We have to connect the column somehow to the base plate also. Okay, and for that, okay, we can use welding. Okay, so otherwise, what will happen? I'm just saying that if this is the concrete base, this is the base plate, and this is the column. If you look from this side, okay, so if we directly keep the column over the base plate without joining the column to the base plate, okay, directly keep it, then there will be chance that the column might get displaced from its position. Okay, so we also have to um, connect the column to the base plate. Okay, and for that we can use welding. So for welding, we can directly design it. Okay, now first of all, we have to know how much length is available for welding. Okay, so let us calculate it. So this much of length is available for welding. So let us find how much will be the fellow. Let us go from this side. Okay, 250 plus this one is 10.6 plus this one is also 10.6. So how much is this? This will be 250 minus 9.4. On this side it is 250. Okay, we consider this edges, we don't consider it as curved, we consider it as rectangle. Okay, it's the same concept that we use while we calculate the area for angles and all. Okay, in the tension members we have already done. Okay, so this one is 250, 10.6, then 10.6, then the on this side this one is 250 minus 9.4. Again on the same we will get here also same. So on the right side also we will get the same value. Okay, then how much is this one? On one side it is 300 minus 10.6 into 2 on one side. Okay, and on the other side it will be same, 300 total minus 10.6 minus 10.6. So that is the total length of weld available. So please calculate it, how much you will get. So if you calculate it, you will get 250, 250, 250, 250, 250 into 4, 300, 300, 300 into 2, 10.6 1 2 3 4 10.6 are there, then 10.6 into 2 10.6 into 2, so it will all be cancelled. 10.6 10.6 10.6 10.6 means 10.6 into 4, then this and this means 10.6 into 4, so all this 10.6 will get cancelled. Then 9.4 9.4 we get 9.4 into 2. So if we do the calculation, we will get 1581.2. So 1581.2 mm is available for welding. Okay, so now what will be the capacity of the weld? Okay, capacity of the weld per unit length. Okay, so first of all, let us consider 8 mm weld. Okay, let us consider 8 mm weld. So after considering 8 mm weld, we have to find out the capacity of the weld per unit length. So the formula for that is 0.7. So 0.7 into size of the weld into strength of the weld. Okay, that will be same as the strength of the parent material. Okay, strength of the plate material, whatever we are using, that strength should be same as here. Okay, we always consider the ultimate stress of the weld, strength of the weld, and the ultimate strength of the material that we connect as the same. Okay, so that will be 410 by root 3 into 1.25. 1.25 we get from page number 30, table 5 for weld. Okay, so that is a partial safety factor, and this 1.25 is for shop fabrication. Okay, if we use field fabrication, we have to use 1.5. So let us find out how much it is. So this is how much we have got: 1060.47 Newton per mm. So after that is the strength of the weld per unit length. So how much length will be required? So we will be calculating it using what? The load divided by strength of the weld per unit length. Okay, load divided by strength of the weld per unit length will give us the what? Length required for the weld. So let us find out how much was the load. Okay, how much was the load given? 1000 kilonewton. Load divided by strength of the weld per unit length, 1060.47. So we find out how much it is. So length required will be 942.97. How much it is available to us? 1581. So available length is more than the required length. So our 8 mm fillet weld is adequate. Okay. I'm just want to tell you that this formula, please remember. Okay, first you consider the size, consider 8 mm size of weld, then you assume you find out the strength of the weld per unit length. So that will be what? uh, 0.7 into size of the weld into, this is the ultimate stress. Okay, and we assume that the ultimate stress of the weld should be equal to the ultimate stress of the material that you are joining, and the material value ultimate stress, it is already given in the question 410, so we will also take 410 because I am telling you repeatedly, for the weld also we will take the same ultimate stress. Then root 3 into 1.25. 1.25 is the safety factor, okay, that we get from table 5 page 30. Okay, for shop fabrication, if we use field fabrication, we use 1.5. So there we got the capacity of the weld per unit length has 1060.47 newton per mm. Now required length of weld is equal to load already given in the question 1000 kilonewton, so 1000 into 10 cube newton divided by capacity of the weld per unit length 1060.47. We divide it and we got the length required as 942.97, which is lesser than 1581.2 available. So our 8 mm fillet weld is adequate. Okay, hope you have understood it. So thank you very much.